Okay, so homework answers, we're looking at shapes. So the paper we did for homework says geometry quiz 3. Let's do the ever popular come around.
40.
Say 40's good.
100.
Yep.
26.
Yep. Yep. Yep.
72.
Yep.
180.
Yep.
1,200.
Yep. Yep. Yep.
40.
Yep.
60.
Yep.
I don't know how to
Ha.
X, Y, Y, something.
Yes. XY for the full box minus half because it's a triangle. AX. Does that make sense now? Okay. 16's in the 800s. No go?
880.
880 is true. 15's almost 200.
198.
It is.
81 pi.
Yep. Yep.
64.
Yep.
16 pi.
Yep.
32.
Yep.
61.
Disagree.
48.
48. Yep.
190.
Yep.
512.
Yep.
384.
Agreed. Can I help anybody on the front? Someday we'll take a test and this will be like part of it. I'll give you another matching sheet to this sheet. Anybody need help on the front? 26. I talked, so I lost track of whose turn it was. Who remembers whose turn? Okay, so we'll go over there. 26. Root 13 is true. 21 is true.
Root 45.
Simplify that. Skip up. Oh, got it.
So 3 root 5.
3 root 5 is true.
5 root 3.
Is on the
Left.
left. How about the bottom?
5.
Agreed. 31?
16 on the top.
Yep.
And 8 root 3 on the bottom.
Agreed. 33?
4 root 3.
Yep. 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 Yep.
7 root 2 for both.
Yep.
17 for both.
Yep.
10 root 2 on the top.
Yep.
10 on the bottom.
Yep.
10
Yep.
4 root 5.
Yep.
2 root 10.
All good. Anybody need help? Anything with shapes?
Can you repeat 33 and 34?
33 would have a 4 root 3 hypotenuse and a 2 root 3 bottom leg.
I love shapes.
Anybody need more shape help? So just try not to forget that until that finals day, which is 2 weeks from today, I think, literally. So
Yeah.
down.
I said, oh yeah.
Yep. Down at the end of your row, I already gave you the notes paper for slope. So today's lesson is about slope. And we'll just field some opinions from the gallery up here. The second piece of notes is flawed because I didn't draw you the pictures, but we can imagine and describe the pictures. Does anybody remember any of the wordy answers on the roughly top half of this page? Not the ABCD math, but the just memory recovery.
Parallel lines, same slope.
It is. Parallel lines is toward the bottom of the notes part. Parallel lines do have the same slope, so that's a thing we'll need to know. Perpendicular lines, you could either say negative reciprocals, or you can say they multiply to make -1. That usually depends on the taste of the author of a book, what they want to say. Is there two different ways to say the same thing? Some people prefer different ways to say it. I prefer negative reciprocals personally, but
Slope-intercept form is the y equals mx plus b.
slope-intercept form is y equals mx plus b. That's true.
What is slope? Is that like the 4 different equations?
Yeah, it could be a word, and then it could be a bunch of different equations.
So steep.
It is steepness, so what is slope? You could say steepness. The steeper the line, the more of a value its number has.
Rise over run.
Rise over run works. Usually you use that one if you're visually looking at a graph and you could just see the dots on your graph paper. You might see how much did it rise, how much did it run from dot to dot.
Delta Y over delta X.
Delta Y over delta X is probably the superstar of those. Another way you can write delta Y is with a subtract problem.
Y1 minus Y2 over X1.
Yeah, something like Y1 minus Y2 on top of X1 minus X2. Or you could have written that subtraction backward. But I wrote those four things: the steepness, the rise over run, the delta Y over delta X, and then one of the subtraction variations just being consistent in the order you
And
subtract.
then, will the what kinds of slopes be like positive, negative?
Yeah, so if we
zero,
want
and
to...
impossible?
Yeah, correct. So the four kinds are going to be positive, negative, zero, and impossible. Just when I made this notes paper, I forgot to put the pictures on it. So show me with an arm, what's a positive slope look like? I agree. People going like this, negative, just like that, zero. Just go horizontal, and then no slope is a vertical line. That leaves us only what is point slope form. So I would say, by way of reminder, point slope form is what you use when you're asked to write an equation. Any of the problems down below, 99% of the time, when you're asked to write an equation, you work through a thing called point slope form. Memory of that? I'll spot you a Y.
Thanks.
Does that have something to do with like the Y1, Y2 things?
It's something kind of like that. I'll spot you a minus, Y minus. I'll spot you a Y1 or a YO, where the 1 or the O is a subscript, like one of those down in the ground numbers. So I went Y minus Y1 equals.
X minus X1.
There's going to be, after the equals, another thing before the X minus X1, and the X minus X1 is going to go in parentheses. It's not going to be a B.
Or is it the M?
It is the M. It's the slope. The slope always has to attach itself to X sooner or later. So we go Y minus Y1, which would have to be given to you, equals M, which has to be given to you, and then in parentheses, X minus X1. These things were not very creatively named. Slope-intercept form is called slope-intercept form because visually you can identify the slope and the intercept. Which number is the slope?
The one with the X.
The one with the X. And the intercept, is it the X-intercept or the Y-intercept that's the other number staring you in the face? It is the Y-intercept, which means it's where we're touching the
Y-axis.
Y-axis. Point slope form is not very creatively named because you'd use that if another human gave you a point and a slope. And then you just stick the right number in the right slot. So when we use point slope form, we write literally the letter Y minus, and then fill in a number that we know for a Y coordinate. It equals, you fill in a slope that you know, have some parentheses, and in the parentheses you do every time the letter X minus, and then some number that you would know for an X coordinate. Question about the notesy part? Okay, so A, let's try to compute slope. The biggest mistake I historically see with people doing slope is they do them upside down. And it's sad because they're all wrong. But make sure the Y's are on the top, make sure the X's are on the bottom. The other thing that I see that's wrong is usually signs. Just make sure you subtract in a consistent order. So if you're going to do like a certain order on one of them, you just have to stay in that subtracting order for consistency's sake. Anybody an opinion?
3/4.
It is 3/4. If you would want to do a quick check of that, one thing you could do is plot those 2 points, and you'd see that it's going uphill, which means it's positive. And another thing it's probably good to just know is, if we think about our XY coordinate system, if you split quadrant 1 exactly in half with a line, do you know what slope that line would have when it exactly splits quadrants? It is a slope of 1. So if you plotted those points, it's like a little bit less steep than a positive 1 slope because it's not quite like splitting the quadrant. Visually, you could confirm those if you had the patience to graph. But it is 3/4. It's a positive slope. It's not as steep as the 1 slope that splits the quadrant. B, you thought? Is negative 13 over 4. If you wanted to visually check that, you'd see that it's running downhill and it's going pretty steep. over 1 square is going to take it down more than 3 squares. It has a slope and value larger than 3. C, it has a little bit of an oddity.
Impossible?
It is impossible, either because mathematically you get 0 on the bottom, or if you plotted those points, how would they position relative to each other?
Like,
They'd be vertically stacked, and we just decided a minute ago a vertical stack has no slope. D is a little bit of an oddity.
0.
It's 0, either because mathematically you get 0 on the top, or through powers of visualization, you know that those are like horizontally stacked, like side-by-side partners. That paper made you do slope 4 times. It kind of had one of each kind of thing that could happen. The homework, I think, has about a dozen of those problems to do, just to test each one, maybe 2 or 3 times. Question about computation of slope? Okay, so 1, we're identifying the slope and the y-intercept, which means it would be nice if the equation were in slope-intercept form, which it is. If it weren't, you'd have to do some algebra to get the y alone. But the y is alone, so we just read those off. The slope would be 3, and the intercept would be, and I prefer you write it as an ordered pair. So is it a -4, 0, or a 0, -4? It is a 0, -4. So we go 0, -4 is our ordered pair. This sheet did one of those, homework does 2 of those. Question about that skill. Then I do what all math people do, let's reverse it. I gave you the slope, and I gave you the intercept, and I ask you for an equation. I earlier said when you write an equation, it tends to be point-slope form, and then I did briefly correct myself, if you noticed, and I said like 90-something% of the time. This is the other little bit of a percentage of the time. If you're given the slope, and you're given the intercept, you might as well jump straight to slope-intercept form. So what will 2 look like?
Y equals -2 fifths x minus 6.
True. Just put the slope next to the x and the intercept on there. So y equals -2 fifths x minus 6. Something about that skill. We did 1. Homework, you'll do 2. 3. You can't right now answer that question immediately. What do we have to do to be able to discuss whether those lines are parallel, perpendicular? Get the y's alone. So on the first equation, if you get the y alone, what is it that y would equal?
-2 + x.
-2 plus x works. X minus 2 also works. Does anybody need assistance or a moment to get to the -2 plus x kind of thing? For the second one, get the y alone.
X minus 6.
Close.
3/2 minus x.
Close.
So x minus 3/2.
X minus 3/2. Because I'd move the 6 to go be with the x, and it would be 4x minus 6. Then when I divide by 4, it would kill the other 4 and go x minus a reduced fraction 3/2. We do that so that we can easily now eyeball what important feature,
X's are the same.
that the xy numbers are the same, which means they have the same slope. So that would be parallel. If I wanted it to be perpendicular, if one of the things was 1, what would the other one have had to be?
-1.
-1. Because we'd want to flip, which would keep it a 1 in that oddity, but switch signs. And then when would you say intersecting?
If it's neither of
If
them.
it's neither of those, then that's your default leftover choice. Although technically perpendicular is also intersecting, but it's not the best answer to say intersecting if it's perpendicular. There's 2 of those on the homework, like the one we did. Question about that skill.
What was the last part of the second one?
Of getting it y equals?
Yeah.
It would be x minus 3/2. And technically speaking, there was another part of the parallel definition that I don't think is going to usually matter, and it didn't matter there, is they're supposed to have the same slopes, but they're also supposed to have different intercepts. Because if they had the same slope
It's the same.
and they had the same intercept, they're
It's the
Same.
just the same line in a stack, and that's not really parallel or perpendicular. I guess technically it is intersecting, but it's like really intersecting. 4 says write an equation. So we're going to try to run through that point slope form. It would go y minus
4.
the 4 equals
2/3.
2/3 parentheses
X plus 3.
x plus 3. And then this is a slightly flawed sheet because I really should have done a note about what standard form is, and I didn't. So I'll just say that and maybe write it down in a big space up above the line somewhere. Standard form is ax plus by equals c, meaning x and y on the same side, get the number out of there.
Wait, what was it?
Ax plus by equals c. And it also has to have a, b, and c being integers. What are the integers?
1, 2.
1, 2. How about -1, -2? Yeah. How about 0? Yeah. It just means you can't have any decimals or fractions.
So just whole numbers.
Just whole numbers. Yeah. Whole numbers, whether they're positive or negative or 0. Yeah. Because the whole numbers technically is the 0 and up part of
Yeah.
that. The integers is the technical name for if we incorporate basically the number line numbers. Any numbers marked on the number line, those are integers. So to be in standard form, our big issue on this is we have one fraction. Your algebra instincts are probably telling you, because of the parentheses, to distribute. But if you distribute in some settings, you're going to get even more fractions. So my suggestion would be don't distribute a fraction where you may get even more fractions than you had before, but immediately act to cancel that fraction. So on the right side, if you want to cancel the 3, you'd multiply the thing by 3. And if you're doing that on the right, you have to do that to the left. So my first maneuver would be to take the y becomes a 3y, minus 4 becomes minus 12, equals, the 2/3 becomes a 2, and don't do multiplication in the parentheses, because when you change the 2/3 to a 2, you did that side already. If you change what's in there also, when it distributes in, it's like you changed it twice. Distribute the 2 gets you
2x plus 6.
2x plus 6. Did I lose anybody getting to 3y minus 12 equals 2x plus 6? Then a little bit of wiggle. Get the x and y both to the left. Get all the numbers out to the right. And how's that going to look?
3y minus 2x equals 18.
That's fine. Could also be negative 2x plus 3y equals 18 if you're a little OCD about your alphabet. Doesn't matter to me. Stuff 4. 5's a little sneaky because I want you to be parallel to this line. So your first thought would have to be that this line has a slope of 3. And parallel means slopes are the same. So when we go to write the equation, just bring the 3 with us and do what we did on 4. We go y plus a 3, because we have a little minus minus makes plus, equals 3 wants to distribute, parentheses, x minus 2. There's no fractions here to kill this time, so just do the distribute, wiggle the x and y to the left, wiggle the numbers all to the right, and then let me know when you hit the final product.
Y plus 3x equals -5.
Close twice misses.
Or -9.
That's correct. Yeah, it's going to be a positive y minus a 3x, or a negative 3x plus a y, whichever way you prefer, and it does equal -9. Anybody need help jumping through those hoops? Okay, 6, you don't have all the information you need immediately to write the equation, because what don't you know?
Slope.
Slope. So get it. Go get the slope. So start off number 6 the way we did those ABCD problems. Slope getting is a third. Anybody need help with slope of a third? Then you have a choice. Some people could do y minus
Negative.
no,
Or 3.
y minus the 3. But other people might choose to do y minus 4. Doesn't matter. You pick. I did y minus 3 equals a third, parentheses. If you picked y minus 3, now your parentheses are
Positive. Like x plus 1.
x plus 1. If you had picked the y minus 4, your parentheses are x minus 2. Just pick one. If you want to be an overachieve checker, you could do them both and make sure they agree in the long run. Slope-intercept form is this set of directions. So the thing about standard form, the no fractions allowed, that's out the window. Fractions are perfectly fine for slope-intercept form. You just need to first distribute, and then the only thing that has to move is the
Next.
minus 3 thing to get the y alone. Anybody yet?
Is it like y equals 1/3 x plus 3.5 or 3 1/3?
That's fine. Y equals 1/3 x plus, and then you have a stylistic choice to make. If you like mixed numbers, 3 1/3 works. If you like to do common denominators and get improper fractions, 10/3 would work. If you have to grab your calculator and push buttons, a 3.3 with a line on that last 3 would work. It doesn't really matter to me what you do with that. 7 is tricky twice, and then we're out on this one. Well, what do you think should happen first on 7?
Find the slope.
Find the slope.
Is it negative 1/7?
Close.
7.
Just 7. Yeah, yours was upside down. So we'll go y's on top. That would get us a slope of just 7. Well, maybe.
Yeah, 'cause
You,
then
you
it
might
has
be
to-
a step ahead of what everybody else was thinking. So what I gave you has to steer you through a 7 first. But then I think you already made a leap ahead.
The
Perpendicular is code to mean
Negative 1/7.
negative 1/7, because we have to make 2 adjustments to into perpendicular world, which is to
Negative.
negative
and reciprocal.
and reciprocal. So 7 becomes a 7th, positive becomes negative. Right after the equals, we need to nestle in there a negative 1/7. And then you have choices. Most people will probably choose y minus 1, because that's simpler than choosing y minus 8. But you could do either thing. And then your parentheses are x,
minus 3.
agreed. And then distribute, get the y alone.
Is it y equals negative 1/7 x plus 1 and 4/7?
Close. 1 3/7. So we can go y equals negative 1/7 x plus 1 3/7 would work, 10/7 would work. I would not suggest you push buttons when it's sevenths because they fill your screen. There is a repeat, but it doesn't repeat until the 6th digit. So you can, but I would not do that. I would either do the common denominator or just work with mixed number, like 1, 2, 3, 4, 5 sheets for 5 people. Scatter those around to each other. That's what would be technically due tomorrow if I would see you, which I may or may not. We had already previewed the next lesson, which was graphing lines, which would be due for after the weekend Tuesday, because we have Monday off. And then next in the queue after that for a learning thing, what is next? Next time we see the full group, it's Circles Day. So Circles Day coming up next.